Today we are going to discuss about the interesting topic about the roadmap on Kubernetes with Sitecore. And today we have Eloquent who is going to present this wonderful session. And Eloquent is more than a decade of experience in the industry and under Sitecore MVP. And currently, he's working as one of the lead developer in Valtech Paris. So that's all about for the session. I think without further delay, we'll get started. Eloquent, what do you?
Okay.
Yeah.
So I hope my screen is visible.
Yeah, it is.
Yes.
Yeah. Okay. Okay. So thank you all for joining with me this Saturday, despite it's the weekend. So I'm very happy to be presenting some of my learnings on hosting the Sitecore on Kubernetes with you guys. And I would also like to thank the CB organizers, Prabhu, Gautam, and Vignesh for having me. Thank you once again, guys. A bit about me. So I'm Ilakwan Rajamani, and I work as a Sitecore lead developer at Valtech Paris. And I'm a Sitecore technology MVP for this year, and I'm having around 6+ years of experience with Sitecore. And for past 2 years, I have been working with Sitecore headless project with the Next.js, which is hosted on Kubernetes. So for today's agenda, like we are going to get started with introduction to Kubernetes, like where we will be seeing some of the key concepts of Kubernetes that we as Sitecore developers are expected to be aware, and it is going to be really helpful in forming the Sitecore deployments. And the second topic is going to be defining the Sitecore deployment and how we are going to do that and what it really means. So as part of this one, like we are going to see so how we are going to form the YAML definitions for our Sitecore instances, which helps to host our Sitecore instance on Kubernetes, because it's going to be a bit different than how we used to do before regarding the Sitecore deployments. And we are also going to see a demo, like where we together going to form the Kubernetes structure for our one of the XM Sitecore instances. So in this demo, like I will not be really showing you in deploying directly to the Kubernetes, but we will be covering only the forming YAML definitions part. And we will be ending up this session, seeing some of the very useful tools that is going to be really helpful working with Kubernetes day to day. So let's get started with introduction to Kubernetes. So when I started working with Kubernetes, what really helped me to understand its concepts was really to compare and see how we used to host our Sitecore site in past versus to see like how it gets evolved in recent times with all these latest technological stacks. And one among them is Kubernetes. And the Kubernetes has benefited us in a way like how we can deploy the Sitecore sites, and how it helps spinning up the multiple Sitecore instances and very faster than how we used to do that before. And with that, if we take maybe say for example around 10 years back, we used to host our site on premises. So meaning that we used to deploy our sites on physical machines, and the physical machine like can exist either within an organization, or it can also be rented from other hosting providers. But like as soon as we get access to the physical server, like we will be start installing the OS, and then we will be start installing all the different softwares like SQL, IS, etc. So even though it offers benefits like having control over full infrastructure, but it has its own pain points. So meaning that The first one is going to be, because as with on-premises, everything going to be manual. So it requires a lot of manual labors working around the clock to maintain all these hardware and software in order to keep our Sitecore site healthy. And the second one is going to be a scalable one. So because the scalability with on-premises is going to be really difficult, because each site each environment that we would like to spin up, we will be doing all these manual activities like installing the OS, IAS, etc. And it's going to be a really difficult one. And from on-premises, like we gradually move to host our Sitecore sites on a virtual machine. So meaning that even though it's a virtual machine, like it's still going to be it's still going to be on the physical server, and the physical server can exist somewhere, and in the sense like in some data centers, and it will be managed by some third party. And this is where the cloud providers comes into play. And once again, like as soon as we get access to the physical machines, like we again will be installing the OS, IAS, and SQL on each virtual machines that we are going to spin up. And so here the one advantages is like all the physical machine like that we are spinning up will be sharing the common hardware, and it's internally handled by the hypervisor. And the hypervisor here is responsible for effectively sharing the hardware between the different virtual machines that we are spinning up. So from this, like is like where we are now, that is containers. So like we as a Sitecore developers are already started working with containers in recent times. So containers are similar to VM, meaning that it has more relaxed isolation. So that means like it has process and file system level isolation, and that allows the containers to be sharing and running on the same OS kernel on which they are running. Say, for example, we in our local, we are spinning up the Docker containers, which is runs on our OS, which is installed in your laptop. And containers are more portable. It is portable because it is basically encapsulated all the dependent softwares within as a single Sitecore image. And because it's portable and it's very lightweight, it is going to behave in the same way how it how it works in your local. Say, for example, like you're shipping and deploying the same image on higher environments, and it is going to be behave in the same way like how it behaves in your local. So here, like we will not be facing the issues like something is working in our local environment and it is not working in higher environments. And because it's lightweight and portable, it basically outperforms than the VM because it has a very lesser startup time. So because like we are not going to install all the manual softwares on top of the containers, because everything comes as an image. And each container is responsible to host only one application. So say, for example, like we have our Sitecore CM instance, and only one Kubernetes pod is going to host that. And similarly, we have the CD and ID rendering host, etc. And each of them will be hosted in individual pods. And containers are, as I have told, containers are built based on the images. So next we are going to see a bit about images. So images are going to be the building blocks of the containers, and images are basically lightweight and standalone and a smallest executable unit. And as I have told, they are the building blocks of the containers. And it is possible for us to create an image based on multiple other images. So meaning that, say, for example, like we are when we build a Sitecore image, like for our solution, like we are going to use the image that is provided by the Sitecore. So like it is not that like we are going to create all the images from scratch, because Sitecore already have a set of images with all the required dependencies for the Sitecore to be running properly. And so like we as a Sitecore developer have already started working with the Docker file, which is basically helps us to build the images. And Docker file is nothing but it has line by line command line instructions, and that gets executed when we actually build the Sitecore images. And it is possible for us to build image based on multiple other images, and we can add as many layers as possible. And as soon as like we build our images, we have to make sure the images are named and versioned. And once the images are built, obviously like we are going to host the images to somewhere, so that the image can be consumed by others, whoever is having access, just like how we are consuming the Sitecore provided images. Say, for example, you're having your XP instance that you would like to deploy on Kubernetes, and it's going to be really a lot of images, and you'll be having a lot of deployments, and also you'll be having a lot of containers. Say, for example, if you take Sitecore XP instance with the headless development, this is on top of Sitecore managed cloud, and you'll be having 34 different images and 39 deployments, and we will be end up having like around 100 plus different containers, and managing them manually will be really going to be difficult, because with managing the containers and handling the replica services, etc., will be really difficult. And we need some solution for this, where we can where these things can be automated. And that is where the Kubernetes comes into play. As we all know, Kubernetes are used to host our containers, and it's basically a container orchestration platform. And it comes with a set of features like service discovery and load balancing. So meaning that each instance that is running inside the Kubernetes, it is possible for us to access the resources with an IP or a DNS host name. And it also has internal load balancing. So meaning that how much ever the load, like Kubernetes will eventually distribute the load across the healthy ports that is running inside it. And it also offers features like automated rollouts and rollbacks. So meaning that whenever we would like to upgrade our application version, it is going to be automated by the Kubernetes. And the Kubernetes will make sure these automates will be smoother, and there will not be any issues. It is not going to impact our already running pods. So when we deploy something new, it will depending on how we are defining the YAML definitions, it is not going to disturb the already running pods. It will wait for the new deployment and new pods to be running properly, and then it will be killing the old one. And in this way, like the deployment is going to be smoother. So in the same way, like if something happens that, like say for example, our new version introduces some bug or some P1s in our site, it is possible for us to roll back to a previous version very smoothly. And it also offers features like automated scaling. Say for example, if we define a auto scalar rule, so meaning that if the CPU percentage of the parts reaches certain level, if we instruct the Kubernetes to add additional parts on top of it, and the Kubernetes will be capable of handling that automatically, and we don't require any manual intervention like how we used to do that in on-premises hosting. And it also have features like self-healing. So meaning that if for some reasons, like one of the Kubernetes nodes or pods becomes unhealthy, the Kubernetes master node will be rescheduling the parts to some other parts, and then it will be recreate the problematic one. And with Kubernetes, like it is possible for us to store very like secret informations like our Sitecore license, and if we have some kind of keys, then we can use the Kubernetes storage management features. In this way, it is going to be really safe. Next, we are going to see some of the key concepts. The first one is going to be the Kubernetes cluster. And within Kubernetes, Kubernetes cluster is everything. Like it is going to provide us the infrastructure and the required resources to host our Sitecore applications. You can think of Kubernetes cluster like cluster of virtual machines that is combined together. And Kubernetes, or each Kubernetes cluster will be having one master node or control plane and a set of worker nodes. The worker nodes is the one like where we are able to host our Sitecore solutions. Say, for example, all our CM, CD, and rendering host instances like will be scheduled by Kubernetes on the worker nodes, and the master node like will be constantly monitoring the worker nodes. Say, for example, if some of the worker nodes becomes unhealthy, then the master node will instruct the worker nodes so that it will get self-healed. And for this job, like master node will be having some kind of API and scheduler within it. And just with the cluster, it is not going to be really helpful because we have some other features for us to host our Sitecore app. And that's where the parts node and the deployment and all these, like whatever I have listed below, like is going to be come into play. So we are going to see them in detail in further slides. The first one is going to be pod. So as I have told, like a pod is a place like where we are going to host our, where we are going to deploy our Sitecore apps. And the pod is the smallest unit of the Kubernetes platform. And each pod can capable of hosting one or more containers. And usually it's going to be one container, but it is also possible to host multiple containers on a single pod. And each pod will be handled and managed by a individual deployment, and we will be seeing what the deployment is in further slides. And all the containers within the pod is capable to share the common resources like storage. And each pod will be having one IP or DNS name, so that this pod can be accessible by different other pods. And once the parts gets created by the Kubernetes, like it has a defined set of life cycles, say like pending, running, and succeeded or failed. And depending on the state of the pod, and the Kubernetes pod will be transitioned between these life cycles automatically. And this is about the pod. And if we zoom out a bit, and that's where the Kubernetes node comes into play. And a node, you can give me a minute. Okay, so node is node you can think of like a virtual machine where we can host like where we are able to run different other virtual machines. And each node capable of running one or more like multiple pods in it. Like just like you're seeing the screen, this is a pod, and it's have different. I mean, this is a node, and it has different pods running in it. So each node will be by default having a container runtime. So in our case, it is going to be Docker, and it also has the kubelet agent. So the kubelet agent will be responsible for to be in constant communications with the master node. And if something happens, it will receive the commands via this kubelet agent. And each node, all the nodes that we are running, like will be managed by the master node. And say, for example, all the resources, the CPU and memory of this particular node will be directly handled by the master node. And next, if we zoom out even a bit, and that's where the cluster comes into play. And this is how a cluster will look like. And here I have defined a cluster with one Windows node pool and one Linux node pool. And you can notice that the Windows node pool is having two different Windows nodes, and the Linux node pool is having one Linux node. And one of the Windows node is having only one part in it, and the other Windows node is having two parts in it. So similarly, like as I have told, each cluster will be there will be a master node as well, and the master node is responsible to manage all these worker nodes. So, for example, if we ask the Kubernetes to deploy additional pod on top of the existing nodes, this request will be handled by the master node. So it will first check whether there is enough resources in the existing node, and if there is no, say for example, there is no enough CPU for the existing node to accommodate the incoming port. So in this case, the Kubernetes master will be creating one additional node automatically, and this spin-up time will be really faster. And once the new node starts running, the Kubernetes master node will be deploying the new pod into the new node. And in this way, the scaling within the Kubernetes is going to be really faster. And the next one is going to be deployment. So deployment represents a desired state of one or more ports. Say, for example, if I have a deployment where I specify I need 3 parts to be running always, then the Kubernetes will make sure this particular deployment will always be running 3 parts. Even if one part becomes unhealthy, the Kubernetes master node will be replacing this one, the unhealthy one, with the fresh one. And the Kubernetes deployment also responsible for other tasks like rolling update and rollback, and scaling and self-healing. And the next one is going to be a service. So now we have a pod running in a node, but we somehow have to expose our pods to as a service, so that it will be accessible by different other pods. Say, for example, we are having the Solar and SQL services running, so that running as a service, so that it can be accessed by our CM and CD instances. And the services will be using the selectors to rightly identify the paths. So meaning that each service will be associated with a deployment. So CM, there will for a CM instance and CM deployment, there will be one service, and similarly for the rest of the instance, like the CD and running host, etc. And the services are responsible for the load balancing, and service will make sure to eventually distribute the load among the running healthy pods. And the next one is ingress controller. So now we think with just the service, it is really not going to be useful. We somehow have to expose our paths to the external outside world, so that it will be accessible. And that's where the Kubernetes Kubernetes ingress controller comes into play. And it's a component that helps to manage the external access to a particular service. So as you're seeing in the screen, consider this as a ingress controller, and it will manage all the incoming traffic and from the outside world, and it will rightly route the traffic to the correct service, and eventually to the correct path. And the next one, as I have told, the secrets. Secrets within the Kubernetes helps us to really store and secure our all the confidential data, like Sitecore licenses. And say, for example, if we have buzzer voice keys, something like that, then it is possible for us to store them in a secure way with the help of secrets. And if you combine all of this, and this is how it's going to look like. Say, for example, we as a client trying to access our CM instance, and that request is going to be handled by an ingress controller, because as I have told, the ingress controller within the Kubernetes cluster is responsible to handle the outside traffic. And once the traffic is routed to the ingress controller, and it will in turn route the traffic to a corresponding service that is associated with the ingress controller. Say, for example, you are accessing the CM. So the route it will be initially handled by the ingress. Then the ingress will route the traffic to a corresponding service. And once it reaches the service, then as I have told, like there can be multiple pods associated with one service. So this service will see which pod is running healthy and smooth. Then it will route the traffic to the corresponding pod. And this pod, all of these pods then can share a secret or config, etc. And this is how it basically works within cluster. Next, like we are going to see how we are going to define a Sitecore deployment. Like so far we have seen what some important concepts of Kubernetes, like, and like as part of this section, like we are going to see how we are going to apply this and how it's linked with our Sitecore deployment. So how does it work? So the life cycle is going to be like, as we as a developer, like will be doing some code changes in our local IDE, and we push the changes to some of the source control repositories, be it Azure DevOps or Git. Then we are going to commit it, and if there is a trigger associated with that, then the Azure pipeline will be triggered, and that is responsible to read the source control, and it will build the images using that. And once the images are ready, then it will eventually be pushed to the registry, as I have told. And it will have the images is going to be named one, and it will have one version associated with that. And we are not going to see much in detail about this part because if I start explaining, and it will be really time consuming. So we are going to only see how we are going to define our deployment using the YAML definitions of Kubernetes. Now we know that. Now let's consider the images are ready. Like we are going to see like how we are going to form the Kubernetes deployment. And so in order to deploy our applications on top of Kubernetes, there should be some way, and that's where the Kubernetes manifest file will be used. So usually, like we can deploy our app to Kubernetes in two ways. Either we can use the YAML definition files, or we can also use the Helm charts. But there is no officially supported Helm charts definitions from Sitecore, so we are not going to see that. But like we will be only focusing on the YAML file. So the YAML file is a file where we instruct where we instruct how we are going to deploy our Sitecore app onto the Kubernetes. So, for example, we can define the scaling strategies. We can also define some auto scaling rules. And we can also define how much memory or CPU can consume like per path. So it is possible for, say, for example, CM, we can define like it can consume like around 16 GB of available memory of the cluster, and CD we can also specify like based on our needs. So like it is not really that we are going to start from scratch defining all the images, etc. Sitecore has already provided the base images, and the base image will be having all the required softwares like IAS and the SQL, etc. for the Sitecore to be running properly. And we are going to use base images provided by the Sitecore, and we are going to add as many layer as possible. Like so, building the images is really going to be slow. So we have to make sure we apply the proper layering technique when we actually define a Docker file. So we are not going to step into that one. Like we will be more focusing on only the Kubernetes manifest files. Again, the Kubernetes manifest file, like we don't have to start creating the manifest file everything from the beginning. If say for example, if I go back, so if you look at our if you look the Sitecore's GitHub repository, and if you take a look at the KH folder, and the Sitecore has provided all the base of the Kubernetes file, which we can straight away download and start using it. And say for example, if you take the SXP, and it is going to have different versions in it. And here, if you check for the Epsum instances, and it will define the CD, and we will be having the YAML definition for CM, etc. And similarly, if you expand the XP, then it will have all the YAML files, like which is needed to spin up an XP instance. And not just this one, it also offers some other images like Horizon, Experience Age, and Publishing. Like it is possible for us to simply download this particular image and this particular manifest file, and we can start defining our site code deployments on top of it. If I switch back to my presentation, if you see like as I have told, for the Kubernetes deployments, the manifest file is going to be a base one. And it can be either in YAML or JSON format, but here like we are going to define the spec in the YAML definitions, because the Sitecore follows the YAML way. And using the manifest file, we can define different Kubernetes resources. Say for example, we can define YAML file for pods. We can define one YAML file for services and deployments, etc. And each manifest file will be having some of the key components like API version, kind, and metadata, and also the spec. And this spec is the place like where we define all our environment variable. We are also going to specify how much resources each instances should use, etc. Like everything will be under spec. And this is how single Kubernetes manifest file will look like. And you can notice at the top that it has API version, and this is something is going to be common and from the Kubernetes side itself. And like you can notice that it is also having one attribute called time. So here, this is an example of deployment. Similarly, say for example, if you have type resources, resources or services, then the time will be changing accordingly. And next, the metadata. So, like metadata tells about the name and different labels about this particular deployment. It is possible for us to define our custom labels, and these custom labels can be used by some other manifest file. We will see that in detail when we are going to demo it. And the spec, as I have told, this is a place where we specify all our Docker image. Say for example, so here I have specified an image. So it is not just name. We have to give a full part of it. We will be seeing in detail why I have specified only the name. And you can also notice that I have specified the replica to be one. So that means like when we deploy this CD instance to Kubernetes, so by default, it is going to have only one pod running. So if I specify the replica to be two, then this deployment will make sure there is always two pods running for our seeding instance. And as we have seen in the Sitecore manifest file, you'll be noticing that it has a lot of YAML files for different instances, and managing them will be really difficult. And Kubernetes also follows the infrastructure as code principle. So that means like the infrastructure can be handled with the help of these YAML files. And we somehow have to have a mechanism where we can combine all these YAML definitions into one file, and then and that file will be able to deploy to Kubernetes. And that's where the concept customize comes into play. Customize lets us to define the config files like into multiple files and combine them together before we deploy the file to the Kubernetes. And with customize, it is also possible for us to create a kind of base set of files, and we can apply the overlays based on our environments. Yeah, and this way the customize is going to be really helpful. So next, there are defined steps like one can follow to define our Kubernetes YAML definition files. So first we need to make sure we properly define the folder structure based on the resources. Say, for example, all our service file, we can simply create a folder called service, and we can have all our service file into it. And similarly, we can create another folder to have the files related to the jobs. The jobs in the sense like MS SQL init and Solar init, as you all know. And once the folder structure is ready, then we are going to create the base manifest file. So base manifest file is going to be a base that can be reused for different other environments. So, for example, we can create a base set of files for our services and ingresses, etc., and including the jobs, and we can override those base files depending on the environment. We are going to see that. That's what I have mentioned. Like overlays is the place like where we are going to override what is there in the base. So, for example, for your QA instance, you will not be using that much resource, so the memory can be lesser. But when you deploy the same to prod, so we are required to give more CPU and memory, etc. So those things like we can override with the help of overlays. Next, we're going to jump in a demo. So as part of the demo, so we're going to see how we are going to define our folder structure and how we are going to define the base config files. And on top of it, we are going to define environment specific environment core events. So I will have to switch to my screen. Okay. So this is a very plain folder that I have created for the demo.
Sorry, Lipan, I'm still seeing your PowerPoint.
On so are you able to see my Visual Studio Code?
Yes.
Okay. So here I have defined a very empty folder. Like we are going to start with creating the structure, and then we are going to start with creating environment specific overlays, and we are also going to see how the final Kubernetes manifest file will look like. So let's start with creating let's start with seeing like how we are going to create the structure. So as I was told, we will be having one base folder, and then we'll be having the environments. So within the base folder, So we are going to group the resource files, group the YAML definitions file based on the resources, just like services and ingress. And say, for example, we can also have jobs. And we can also have volumes. So this is how like we have to structure our Kubernetes folder within the base. And now let me just copy paste one. Now, like as I have told, this is a CM service. So I will be having this file into my service one. And here you can notice that as we have seen, it has API version specified, and the kind is service. So the YAML definition file for the service is going to be a really smaller one. So in this case, I'm having both the service and deployment in a single file. And here you can notice that the service is linked with an app CM, and which is the deployment. And if you take the deployment, if you see your deployment, we can notice that the kind is going to be deployment. And I have specified the metadata like simply name, and I have also I'm also having some custom labels like app and CM. And this custom label, you can notice that is used by this corresponding service. So in this way, this service is linked with this particular deployment. And as I have told, we'll be having the spec also, where I have defined the replica count. For CM, it is going to be one instance. So I have just specified the one, and it also has other some mandatory properties like selectors, etc. And here, if we come into the specification part, you can notice that I have specified the images. This is actually the your Docker image, but if you give like this, it is not going to be work, because we have to provide a full complete URL to your Sitecore image where it's hosted. But I will tell you like why I have given it this way. And within the spec, we also notice that we have different environment variables. You see, like all the environments variables used by the CM instance is specified within the spec. And what else? And if I scroll down, you see like it is also having some properties like liveliness props and startup prop. This one is it's again a feature offered by Kubernetes. And you can notice that like we are using the this particular path that is given by Sitecore out of the box. So that means like this particular deployment will always keep polling the this particular URL to rightly identify whether the app is healthy or not. If for some reasons so this prop fails, then this particular deployment will become unhealthy. And you can also notice that I have specified, we are also having some volume mounts. So volume mounts is similar to say for example, all the logs created by our CM instances will be accessible from this network volume. I will just explain this what it is later. And yes, that's all about the CM. So similarly, like let us take a look at the CD instance. I'm just going to copy paste. And this is the example of CD. It will be more or less similar like CM in the way that we are having a service, and then we are also defining a deployment part. And you can notice that the name, the metadata is changed accordingly. And again, it's going to have the container, your path to your CD image, and if I scroll down and see, you can notice that this is where I have specified the resources, and within the resources, it is possible for us to define a minimum amount of resource and the maximum one. To specify the minimum one, the request is going to be useful. If I specify it is like 16,000 millicore, then so when this particular part gets deployed to a Kubernetes node, it will make sure it is going to reserve the 16 millicore memory for our CD instance, and the max limit is the maximum one. It will not go beyond 2,500 millicores, and similarly the CPU will not exceed beyond to this level. So now, we have two files, CM and CD. So somehow, like we need to somehow consolidate this file together so that we can deploy to Kubernetes. So that's where the customize, as I have told, will come into play. So here you see, like each folder, it is possible for us to define one customized file. And the customization file, again, it has API version, and it's from Kubernetes itself. It's a default one. And here, you can notice that it's a customization file. And this customization file will include two resource files. So like whatever like we are having here, like CM and CD. So when we build this customization file, it is going to group these two resource files together. That's what that is one of the very useful benefit of customizing. This way, we can group all our different files in different folder and define one customized file. And we can also like define one customized file at a root folder that again group all our resources together. Like we will be seeing in the we are going to see that in detail. And as I have told, this if I specify my image like this, it is not going to work. So here I have specified the images, like I have given a name, Sitecore XMCD, and I have given the path to my full URL to the ACR. So similarly, like I have specified a CM image and the path of it, and you can notice that it also tagged. This is the tag version, but it for now I have hard coded it, but it also depends on your Azure DevOps build version, etc. And so you can notice that here I have given the name XM Sitecore XM on CD1, and that's what I have used it here. So in this way, like you can define the other instances like ID, rendering host, etc., and all your images can be specified over here. Now let's see, like okay, now I'm going to build this customized file using the kube serial command. Like the command is going to be kube serial customize and the root folder of this one where there is a customized file exists. And if I run this one, I think there is a mistake. I think it's because of this one. Let me remove it. Yes, now if I build it, you can notice that the customized file combine these resources together in a single file. You see, like it combined the services from the CD and the services from CM, are also and also the deployment CD. And the deployment CM, it just combined together. So similarly, like it is possible for us to group our SQL init jobs into this folder. into this folder like this, and then we have to define one customized file. So we to tell to consider these resource file when the customized command gets executed. So that's what I have specified. So similarly, we can have volumes also. Similarly, we can also have the volumes and other files, ingresses, etc. So at the root folder, we have to have one customized file. And you can notice that I simply pointed the root folder of each one, like ingress, job, services, etc. Like ingress, job, services, etc. So when I run the customize command against the root customization file, then what it is going to do, it will consolidate all the files from all the resource file from this folder, and it will produce one single file. Say for example, yes, if I run this, then there, yeah, so there is a missing customization file. 1 minute. So I'm just going to have one empty file to resolve this issue. And now if I run it, and you can notice that this customized command has consolidated all the files together, including the jobs. You can notice that the customized command has consolidated all these resources in a single file, and it is possible for us to deploy this single file to Kubernetes. So now we have seen how we can create the base file. Let's see like how we are going to define our environment specific overlays. So within this folder, like I'm already having one base set of manifest file that is required to run a single XM instance. As you're seeing, like it has like CM, CD, ID, etc., and it also have some init jobs with like some of the external YAML definitions for SQL, Redis, Solar. So I'm having it, and if I build this base file, yeah, it is actually working. Now let's consider that you're having two different environments, QA environment and staging. So QA environment, we might require different set of resources, and for the staging it can be a bit higher. So let's see like how we can override these resources using the customize command. So I'm going to create environments in just one environment folder, and within that it is possible to define as many environments as possible, like PA, staging, and then prod, etc. So now we are going to see how for the say for example, let's see key environment. We are going to override the resource limit. So I'm going to create one folder like resources. Give me a minute. And here for the CD instance of the of my QA environment, I'm going to have memory limit of this one, and the CPU, and the maximum one, it's like 25 millicores. That means like 25 GPs. So I'm trying to override this particular resource of my QA CD instance. So similarly, I'm going to have one CM. So now we have created two overlays file to override the resource limit for our QA instance from our base set of files. So now we are going to define how we are going to apply the overlays. Let me just create one customization.yaml. So within customization.yaml, so this thing is going to be same for all. So now I have to tell to use the base file from this base folder. So that's what I'm going to do. Okay, now I have told my this Kubernetes customization file to use all the base file from this particular base folder. Now, then I'm going to I'm going to apply the patch, which we have defined in this resource folder. So I'm going to define, tell patches. The path is going to be resources and cd.yaml. So similarly, for the CM. So now I have created a customization file that will apply, that will read all the files from the base one, and it will apply the patch one. It will apply the config from the patch file. So now let me switch back to this folder. Okay, now if I run my Kubernetes command, now I ran a kubelet customize command from this QA folder that has only one customization file, and you can notice that it basically reads all the file from base folder, and then it has applied the overlays. You see, it overridden the CD environments. I mean memory limit, like memory and CPU limit, like whatever we have specified here. So similarly, if I go and check for this one, you can notice that for the CM instance, the memory limit got overridden by this customization file that we have created. So in this way, it is possible to define different set of resource file within our prod folder and for the stage environments also. And apart from that, other advantage is like, again, the URL is also going to be different. Say, for example, for the prod, the URL of your instance is going to be different, and the K8 is going to be different, and stage is going to be different. So now let's see like how we are going to make use of this customize to override the URLs. So I'm going to create a folder called config maps, where I can define all our URLs. So for example, I have created a file where I can specify my QA CD URL, and similarly one file for the QA CM instance and for the ID one. So now I have created a config map. We are going to see how we are going to utilize the customization to generate and replace the config maps. So we are going to use the config map generator. Give me a minute. Yeah. So here you can notice that I have used the config map generator. It's again a feature offered by the customization, and I have defined a name, and I have told to consider the files from this folder, like whatever I have created now. Config map CD hostname and config map CM hostname, and the config map of ID. And I have also defined how this config map generator is going to read that file. So the name is going to be CM hostname. So that means like the value that we specify within this file can be consumed using this particular name. And this is a default syntax of reading a config map. So similarly, I have specified for the CD that reads the value from the CD file, and similarly for the ID. So now, and if I go back to the base and if I check my CM, and 1 minute. Yeah, you can notice that I have created a placeholder and I have given a name, CM host name. So when you run the customization file with this one, so the customization will replace this value like whatever we have specified over here. So let us try to run. So now I have included the config map generator. So like we're going to see whether it is going to replace it. Yes, now it got generated. Let me switch to the CM instance. You can notice that the placeholder from the base CM file got replaced by this particular config map that we have here, key ACM, and similarly the ID also got replaced. So this is how we can create environment specific URLs. Similarly, like we can have the same, we can repeat the same for different other environments and change the value here. And the other feature, like, so we can also define the ingress. I mean, ingress files, as I have told. So like so far, whatever we have seen, the services and etc. will be accessible only within the cluster. But we somehow have to expose our apps to the outside world, and that's where the ingress controller will be useful. And the ingress controller for CD instance, like will be looking like this, and you can notice that the API version is same, and the kind it's an ingress one, and it has some metadata. And this ingress is a type of Azure App Gateway. So that means like it is going to create some rules and entries directly in the Azure Application Gateway. And we can also specify the whether it's going to have some certificates. We can also specify the certificates within here within the annotations, and we can also specify the request timeout value here. And in the spec part, I have created a rule, and I have defined the CD host name, like whatever like we have specified. So it is going to be replaced for the ingress also. So the CD name will be replaced here. And you can notice that I have specified a rule to handle, to route all the traffics to the, with this host name, will be routed back to the service CD. So what we have seen here. So when we access the CD host name, as I have told, it is initially going to handle by the ingress controller, and it will see what is the corresponding mapped service. In this case, it's going to be CD, and it will route the traffic then to CD services. And within the CD, and you can notice that we have linked the CD services with our CM deployment, which controls the port. So in this way, the traffic will be routed starting from the ingress till to the path. So similarly, we can have all our different ingresses for CM and ID as well. And we have to specify one customization file also. And like here, you can notice that I have created a customization within this folder that includes these resources. Now we have to tell that I have to tell to consider this newly created ingress resources also. So I have just specified the root folder of it. So now if I run my customize command again, then you can notice that now it has also considered my ingress YAML definitions, and it also included them. And you can notice that it also replaced the corresponding my host name. So this is how you can specify environment specific overlays as you need it, and apply the overdens based in the base file of it. So the final one will look like something like this. So like you're going to have base set of files that define different resource types, and then we'll be having different environment specific overlays. Depends on the environment. So QA, staging, or prod. So that is about it. So now, like we have seen, like how we can form our Kubernetes, I mean YAML definitions, and how we can utilize the customized commands to group them together. So now you can create some sort of PowerShell script where you can have these commands, and then you can directly call the those file directly from your Azure pipeline. But we are not going to deep dive into it because it's a quite a lot of complex one to explain in a single session. So now if I go back to my presentation. Okay, so now we have seen how we are able to structure our Kubernetes like YAML definitions. So we are also going to see some of the very useful tools that is going to be really helpful working with Kubernetes day to day. The first one is Lens. So this is a tool, easy use. It will be very easy to use this tool because it is not required to aware all the complete kubelet commands to use this tool. You can simply configure different clusters within this lens. Say for example, KA cluster, and the same way you can configure your stage cluster, prod cluster, etc. And you can switch between different clusters easily. And you can also go through different the different types of resources like pods, deployments, etc. Say for example, you would like to restart or delete some parts manually, then you can simply select that one and you can simply delete it, and Kubernetes will automatically recreate it as soon as it got deleted. And it offers it's a pay for use one, but it's having a free subscription also. You can try it out. Otherwise, it is going to be around $20 per month. And the next one is Azure Portal with the AKS cluster. So here also, like you can directly jump into the portal.azure.com, and where you can see all your clusters there, and you can navigate through your different clusters, and from there you can directly see the logs, or you can restore the pods, etc. But from my experience, the Lens is going to be really user-friendly one than the Azure portal. So that's all like I have for today. So I hope you found this session very valuable and useful one. And thank you all. In case you're having some clarifications about this one, please feel free to ping me in the in my LinkedIn handle or Twitter.
Yeah, I think one question from Karthik.
Yeah. Let me just check. We have some basic requirements to use Hyper-V. Means different environments. No, like Hyper-V, it's going to be for your local environment. So it's not Hyper-V is it's all for your local. So I don't think it is going to impact any cost when you deploy your Docker, when you build your Docker images for your higher environments. Hello, Karthik.
Yeah, I think we understand that. We believe.
Okay.
Team, do you have any questions?
Okay.
Okay.
Yeah, I can't able to unmute myself. That's I think now I can able to unmute. So whenever I was using like a Docker, I was facing some system requirements in my local as well. I'm saying, so
Yeah, correct.
it is yeah.
I think when you use the Hyper-V, like you will be end up facing some issues. Maybe like it
Okay.
depends on your system as well.
Okay.
Maybe like you can share the exceptions, and it will be really difficult to explain them in this call. Maybe you can ping me over LinkedIn. I will
Yeah.
try to help you out.
Yeah. Yeah. Sure. Sure. Thank you. That makes sense. Thank you.
Yeah. So,
Any other queries?
yeah, I think since this is a very cutting edge technology and it is very essential for all of us to grasp it and to effectively ask many queries, I believe. So I think it's a kind of a truly been a productive session, Eloquent, and I think we have gained a lot of valuable insights. So thank you for this session.
Yeah, thank you all. Thank you, guys.
Thank you, Eloquent, for a wonderful session. Thanks for presenting.
Thank you. Yeah, thank you, Vignesh. Thank you, guys. See you soon in the next session. Have a great weekend.
Thanks, everyone who was joined.
Bye.
Have a happy weekend. Bye-bye.
Happy weekend. Bye-bye.